Hi, good morning, everyone. I think this is 9 o'clock, and let us start the
recording in progress.
Let us start our meeting in Craniofacial Research Center. Today, we're honored to have Professor Kuan-Fu, Professor Chen, to talk about biostatistics and also the machine learning. And he will introduce software. I think this is free software, I guess, so that we can use the software. I think for our research people, the biostatistics is important, and machine learning also is recently very hot topic. Professor Chen, after medical school, he received his PhD degree in Johns Hopkins University, and he now serves in Keelung Chang'e Memorial Hospital and also Chang'e University, and he is a physician scientist, meaning that specialized in doing research. And his interest and also specialty include clinical investigation, biostatistics, and also machine learning AI. So let's welcome Professor Chen. Professor Chen, please.
Thank you, Dr. Lo, for your kind introduction. And I still remember that a couple years ago, I was invited to your group, and one of the questions I think is raised by Professor Huang is whether there's a free and easy to use software that you may be utilized to do some simple to complicated statistical analysis, as well as the meta-analysis you were trying to promote at that time. I couldn't find any great software like this at that time, so the only software I could recommend is such as the review manager used by Cochrane. But nowadays things have changed. I won't have the much in-depth introduction in terms of the machine learning, but I do want to have some basic knowledge in terms of all my audience. Like if you can just raise your hand, I don't know what we can do in this kind of interaction, but if you can leave a message or raise your hand, somehow tell me that you are now doing machine learning. Can you just raise your hand or leave a message? Then I can just just allocate my time for more in-depth introduction. If not, that's okay. The other thing I want to know from you is I know that some of you has done some systematic review and meta-analysis. So if you have done that in the past, please leave a message or raise your hand as well. And the other thing is I want to know that whether is there any of you has downloaded that software, because this should be very easy software. I know I probably have 90 minutes, so I will leave maybe 10 to 20 minutes for QA. That means I will have up to 70 minutes. I can lead you step by step, but I know it's going to be very difficult to do that remotely. So let me know if you can just follow me step by step, so I can slow down if any of you met some problems. Really follow my steps. 那我也会稍微用中文，好，如果有一些大家在英文的那个专有名词就听不懂的，我就会用中文再跟大家再解释一下，好，所以如果你已经下载了 ，if you have downloaded the software, the QR code here is not a software itself, but the data set, the demo data set that I think you can use. 这个是一个资料哈，一个资料库，然后是 this is a real data set that I will use to demonstrate throughout the course. And I will also give you this handout. You can have the QR code at the end of the presentation. So if you miss anything, you can come back to use this QR code to download the database if you want. So let me start with the software. It's called JASP. It doesn't have very interesting story behind the scene, but I figure out is they use this acronym is the Jeffrey's amazing statistical program to recognize Bayesian pioneer Sir Harold Jeffrey. 所以它这个只是一个I think they didn't dream big initially. They just want to have a very easy software that you could use to teach your students to demonstrate some statistical analysis. So if we come back to this homepage, you could just hit the download, and that will lead you to download page. Whether you are using Mac, Windows, or Linux, you will be leading to here. And this is very simple and straightforward. And I also want to introduce you some of the feature in this website by going to the feature. Oh, before I go deeper, I must have a statement. I don't have any conflict of interest. I don't have their stock. I'm not there. So I don't have any conflict of interest to declare. But if you click the teaching, you can now know that they have many resources that you could access. But before I go deeper to the resource for teachers, I want to show you that JSP around the world, and we only have 2 institutes registered here as the user in Taiwan, and one is actually Chang'an University. It is actually me who sent an email saying, hey, I'm teaching JSP here. So this is another thing I want to introduce before I go deeper to the resources for teachers. And here they do have lots of documents, and they are all free. Take this one for example. This is it's actually an animation, and I actually downloaded that in the PowerPoints. So you can see here is how you can easily open the data, and which I will do that in real time. Alright, so this is the first thing I want to show you, that this is really a useful source here. And then this is the data library. Let me just go to the software directly. 所以我不知道大家有没有办法已经有这个软体。If any of you have installed the software, I will just start it right now. So after you start the software, because I just used the full page. After you start the software, you should be able to see there's a main menu over here. You can just open. Here in data library, you have lots of demonstration data set. You can see from the simple descriptive statistics, t-test, ANOVA, regression, and then if you are doing some qualitative analysis, here's the one you want to have, is the factor analysis, up to machine learning. You have some demo data set, and then meta-analysis. Let's go back to the descriptive one. So again, you are coming from the main menu, open data library. These are the demonstration database, and then they have some description in terms of what the data set is about. So this data set named Sleep is about the number of additional hours that each 10 students have slept, blah blah blah, and they are telling you that this data set is used to demonstrate how to have distributed statistics, and the data set is actually included in R. So back to their backbone, they are not really developing new or novel or some statistical software that they didn't have. They're just developing a interface, a graphic user interface，就是一个互动的界面。Because using R, you need to know the programming, you need to know how to code, right? So using R is very painful, and they just relieve the painful and lead you to the next step. 所以你就不需要在像用 R 的时候要知道怎么写一些程式嘛，好，那个应该是让你可以更简单来用哈。So like this is the R code, and they are actually using the code from R. So if any of you has used R in the past, you will be familiar with the figure they were able to produce by using the JASP software. And what happens if you click the open JASP file? It will just open a new JASP window. Like I have one window for my demonstration codes, not really codes, demonstration log. And this is the one we just opened. And you can see the interface have different panel. So the first panel I have already added many things here. If you just click plus, it's gonna show you the module menu, and I just add everything. What happens if you just cancel that? So for example, if I just took Cochrane meta-analysis out, it just disappeared. Okay, so if you want to check why you don't have so many items on the panel, you can just click the module menu and click Cochrane meta-analysis, and it's back. It's over here. All right, and then back to the lower parts of this software. There are a small arrow over here. If you click that one, you can see your data. This is very small and simple data set. So it only has 4 variables. One is ID, one is group, one is extra. And we don't really know the we don't really know the data set well. So if you just click again, what I did is right here. Click this one, it's gonna hide the data. And there are 2 windows over here. The left one is the operation panel, so you could just choose anything here, like you could just have a, I don't know if they allow for frequency table, because there are no frequency. So this is the first panel you're gonna have, so you could just collapse that one and expand that one. There are 2 more collapsed item option over here. One is plots. This is why you have I call it sexy violin plots. It doesn't really look like violin, but it's very interesting and easy to use. And you can also have the scatter plots. Maybe not many things here. If you just click this one again, you hide the input option. You're gonna have the outputs only window, and you can also easily export the results to either the HTML file or the PDF. So you could just discuss with your mentor what you find by using this simple function. So let me show you what I have in the demo dataset. So again, let's take a look at the database. The QR code you just scan, you can find, we have up to, I think we have 14 1400 subject recruited in my previous sepsis cohort. And we have the death status, which is actually the same. We call that sepsis associated mortality. So, but basically are the same. We have age, temperature, pulse, etc. So what I did for the descriptive statistic, I just tried to put all of the variable in here, so that make the data set really huge. It's very big data set. But you can still use the I think is Control minus in Windows, because on Mac is Command minus. You can just decrease the font size and make you to know your data better. So here they have the missing values, the mean, standard error, standard deviation, skewness. They even have superior will test for normality distribution automatically. So if you want to have these statistics, just check here. You can see that's why we have missing. And then they have the Shapiro Wilk test, and also show you the skewness, kurtosis of this data distribution. You could just also ask for standard error or standard deviation here, or even the IQR over here. But this is not sexy, it's not, right? Because all these are numbers. These are very boring numbers. So the same for descriptive statistics. You can have different plots over here. You can have distribution plots, like we have bimodal normal distribution for age, but for temperature is very normally distributed. And of course they are all febrile. Most of them are febrile. And you can also have a smooth distribution curve over here, so that's why we have for age. And you also have the rock mark, and for the box plots, you can just add a function for the violin is actually distribution over here. They are symmetric, so one size is enough, but maybe two sides just emphasize the distribution. And you can also ask the software to show you, maybe you have some outlier over here. For example, the SOFA score over here, we have some outliers, maybe very sick over here. And because we also check some biomarkers like the CD64, ICAM, elastin, the CRP, lactate. For the clinical variable, we probably know better about them, but like take lactate for example, we still have some outlier, which is incredible even for clinicians. But for some biomarkers that clinician might not be familiar with, take CD64 for example, I don't really know the normal distribution. What I need to do is check the outlier, maybe take them out before I jump into analysis. So this is very sexy function that you can know which subject is actually your outliers. And then is the QQ plots. QQ plots stand for the quintile distribution. So on the y-axis is the sample quantile, and the x-axis is the theoretical quantile. And here the theory is the normal distribution, so you can know they are really not normal distributed. And these for these biomarkers. Let's take a look at our age and temperature. As I just mentioned, the age is not really normally distributed. We have bimodal distribution, but for temperature, they are really very normally distributed. So again, these are the plots we can check for the distribution. And then you can just ask them to just jump up and down. Oh, I'm sorry. For the scatter plots is over here. This is another sexy plot I always like to have. Here you can check the interaction or the distribution. For example, the age and temperature, they are not really correlated, but I want to check if any biomarker or physio marker like saturation is correlated with age. The older the patient, the lower the saturation they would have in our data set. the same for the coma scale, and the higher SOFA score was found for the elder patient. And for the biomarker, there are really not very much correlation except for like PCT. And you could just ask this software to give you, if you're confident that you should have a linear distribution, let's just ask them to do this. Let's go back to the, because it takes time. So if we just go back to the demo data set, they have extra as a normal. They only have this one, so this is not a good data set to demonstrate, because for scatter plots, what we always want is 2 variables. So that's why they don't really have scatter plots here. All right. So maybe our data set has done that. Since this is a large data set, what I just demonstrated is the efficiency of R. R is able to do some very sophisticated analysis for free, but it's not very powerful by, say, using the computer power. But you can see now they are the regression line. There are not the smooth regression line anymore. So this may not be the correct association we want to have for the database. Okay. So do you have any question? Can you just follow the step, because what I'm showing you is very detailed operation. I'm not sure whether you really want this introductions. Just stop me anytime if you want to know better. Okay. 你们有跟上吗？如果大家有安装的话，我不知道有没有跟上哈。Okay. So this is the first visual distributed figures. While we are waiting for the software, I can just show you the log I have previously. It's over here. This is what I have. I told you that we can just save this. Okay. So we can also have some pie chart very easily. And again, this is the scatter plots. They not only show you the correlation, but also have a very sexy distribution over here. So again, this is the distribution of age, and this is the distribution of this biomarker, pentraxin 3 and CD14, etc. So you can know the database a little bit better. So that's what I always preach is don't just do the hypothesis testing. Don't just look at your p-value. Look at your data before you really do that. And now using JASP, you can just see the data very easily. Okay. So these are the scatter plots, very huge. All right, let's move on to t-test. While it's still doing the analysis, we can just click again, open data library. Oh, before I go to the t-test, I want to show you what if you want to use your CSV, because you can only use CSV here. Like here, navigate to the folder, and here you can see the CSV. I just show you the QR codes. If you just scan the QR code, you're gonna use the database. So you can just use the computer to open the data on your computer. Okay. And let's just go to the data library to go to t-test again to see what they have. They really actually have a large database for t-test compared to the descriptive statistic. And here they have a database for independent sample t-test, They also have some Bayesian version of independent t-test. They have pair t-test and also Bayesian. Oh, this is still the independent sample. So let's check the weight gain here. I should open a new data set here. So again, check the data set first. They have weight before and weight after, and then they have the difference. Unfortunately, I don't think you can just do some calculation by using this function, but you cannot manually add data set here. They don't allow you to do that at this point. But if you check the sample inputs, they really actually have descriptive statistics first. Let's just make it bigger. So you will know that the database, as we already checked the data itself, is for weight gain. So you have weight before and after variables. They also show you the reference if you're interested. And then you have the one sample t-test result over here. Here. Oh, by the way, now we have the two variable we could use for maybe say the scatter plots over here. Scatter plots, they're doing, is that right? Oh. Oh, because we only have difference. Let's take difference out. And then I think the scatter plot they're gonna have looks like this. One's before and one's after. So for the t-test over here, now you have the option to choose from student t-test, which is the parametric t-test for independent samples. You can also choose the Wilcoxon Sign Rank test, which is actually non-parametric. So you can see the p-value are really not very different. The data, this analysis still telling you that the two groups are different. I mean, the difference are statistically significant. So, and you can also have some rank plots. Let's check if I can show you some plots here. Go back to my data sets. Over here. Still running. But just, so let's just check this one. So here I just check, I use the independent t-test to check the difference between the deaths and the survivor. So you can see is over here. You can see all the dependent variables, all the continuous dependent variables are here, and the grouping variables are here. And the hypothesis is the two groups are not equal. So remember, this is the independent t-test. And then I also want to check the normal distribution and equality of variance of two groups. Because if this is violated, we want to use another way to calculate. But unfortunately, you cannot do that here in JSP. 如果两边的 variance 不一样的话，
我加过了。好，那你看约诊的情形怎么样？你再跟我联络，好不好？好。
So this is the assumption check. 我们在看我们的这个常态分布哈。It automatically check all the continuous variable.
所以我会先约一个7月18号。
我们可能要静音一下。
麦克风没有关。啊？嘿。
And here is also the test for equality of variance. Very simple, right? Previously, we might need to write different codes for that. Or you might need to remember the function in some other statistical software. And then here's the rain cloud plots. You can see the distribution of two groups. So the survivors are older than the. Okay, you can see the distribution again. For pair t-test, because I don't really have good example in my data set, I just use systolic blood pressure and diastolic blood pressure. And they are really not, they are really different. Okay, so back to the demo data sets is over here. Now you can see they also give you the option of this rain cloud plots. All right, so next is the ANOVA test. I'll just introduce you that there are so many options here for ANOVA test, because for some people who are doing the wet lab statistics, ANOVA is actually the one you want to really dig deeper. So I collapsed lots of options over here, but I just want to point out I also have the assumption checks, again the QQ plots, and the post hoc test is very important, because when I review some of the journal manuscript, some of them might just miss this one, because after the ANOVA test, what you want to have is to test the difference, the pairwise difference. Say you have 3 groups, then you have 3 additional tests to do. So you want to adjust the multiple comparison here. And here you can just choose Bonferroni or Tukey. The default is Tukey methods. And you can also have some figure, again, rain clouds, or they even provide a non-parametric text. So I think I can just move on here. Yeah, here's the t-test figure. I shouldn't click that regression line before we start. But we have the log over here. You can see for the ANOVA test, I want to know the PCT, the procalcitonin, one of the biomarker for sepsis, whether the distribution is different in the different SIRS group. SIRS is systematic inflammation response syndrome, the previous definition for sepsis. So for 4 groups, you can see if you score 0, you will have very low PCT level. But for the other, they might be very different, although the p-values are still significant. But we know that the ANOVA test, the null hypothesis is that all groups are equal. So you already visualize, you already see that group 0 is very different from the other groups. So you might want to do some post hoc comparison. So this is comparing group 0 to group 1, 2, 3, 4, etc. Group 1 to group 2, 3, 4. And now you will know the P for Tukey is, this is, oh, they don't really have the original p-value. But I think these are adjusted. So you can just use 0.05, the same 0.05 as your cutoff. So you can know that, as we know that group 1 is not very different from group 2, group 2 is not very different from group 3, and group 3 is not different from group 4. So you point out that there are still some, difference between group 4 and group 0, which is very low to very high. And group 4 to group 1 is still significant. And all these are automatically done by the post hoc test. And then Kruskal-Wallis test is the non-parametric version, and this is still significant, but they don't really have the pairwise, the post hoc test for that. Okay. All right. The next one is the regression test. I just use the logistic regression for example here. So you can see here. Let me just. This is meta-analysis. So here. Up here is my logistic regression. So you have your dependent variable, you have your covariates, you have stepwise methods. You can just choose backward or forward. Let's not do anything here to slow it down. You can have a model fix, and then you can have lots of statistic for you. You can have the regression coefficients. You can actually just show you odds ratio or not, and you can diagnose the multi-collinearity here automatically. And on the right one is very similar to the performance metrics that machine learning algorithms often have, because machine learning, although we have some novel machine learning method, many researchers still treat like logistic regression or generalized linear regression as one of the model that you could use. So here you have all these. You can compare with other machine learning models. I will show you all these machine learning models after the meta-analysis part. For the figure, again, we can have some diagnostic figure. For the residual plots, we want to see if there's any outliers, and we can also have our RC plots. If you don't really know RC plots, you should check wiki. You can know that it's called a receiver operating characteristic plot. It's not related to Taiwan, so RC is not Taiwan here. It's just supposed to be a joke. Okay, and you can also have the PR plots, which stand for precision recall plots. We will see that in a minute. Okay, so here's the result for logistic regression. They have 13 models automatically produced, given by the machine, given by the software. So they actually are doing the stepwise method here. The state-of-art stepwise model actually is the backward Allen-Caddy model, but again, it's take some time for this. But again, you can see that there are so many models here. You can just compare. I just want to see if they have the information criteria over here, but they didn't have. We often not, by comparing models, we can compare their area under the curve if we want to do prediction, or if you want to know the model fitness, we could just check the information criteria. But unfortunately, they are not available for JASP yet. So again, JASP is very powerful, and they are updating like in the monthly basis, but there are still lots of functions not in here. And another important thing we want to know is, maybe you want to know what's the package they use for R. Say, if you're really interested in doing some in-depth analysis, you want to know the codes. Maybe they can give some codes, because behind the scene they are all codes that produce automatically by this interface. And I checked the website. They say they will add this function in the future, so you might be able to learn a little bit more of the software. So we can check again. These are the same outputs. You can see they have estimates. Oh, these are bootstrap results. Let me just cover here. And this is the result for 13 models they have. So you can have the odds ratio, like the odds ratio for respiratory rates is significant, and they have a confidence interval. And the bootstrap is another way to have to overcome maybe some violation for the parametric test, because for regression you want to have a normal distribution, and we know some biomarkers are not really distributed normally, so you could just have the bootstrap. It's the resample methods, so you could just use that. Take this one for example, they have 5,000 resampling here, so you now have a more confident distribution of your odds ratio and their confidence interval. And that's also part of the option here, bootstrap. Okay, any questions so far? Is there anyone really trying to play around with this software? 有没有什么问题呢？到现在 If not, I'm going to continue the demonstration for meta-analysis. And again, we can all collapse these. And I just found this option like during the weekends, and this is a very sexy option. And by clicking on this one, you could just do this again very easily. So if you click on the classical continuous outcome, then you can just choose. Oops, I don't know what's going on. Let's go back to here. You can just choose from the topics, and what I chose is oral health databases. Remember, these databases are all from Cochrane, so they are published somewhere, in the Cochrane library. So, and then you could just choose the selective review or meta-analysis. And what I chose is, you can see there's lots of different demonstration database. So here's the 4 mouse treatment modalities for chronic periodontitis in the adults. I'm not really I am really naive in terms of oral hygiene, but there are really lots of interesting database here. So maybe some of you know this meta-analysis. So if you click that one and choose the individual analysis, again you can see the distribution like here. 这里就是很多的资料库哈。There are some distribution of this database because you have how many data here? You have, I think it's 12 studies here. All right. So the sample size range from very small to not so small. They are all small, right? So that's why we want to do a meta-analysis. So if you click that one, and these are all these very simple distribution plots, and let's expand the statistics because we don't have some model here. What they're showing you is the intercept distribution. So the estimate, confidence interval, and the model fitness, they are really not really sexy, right? So we want to see the forest plot. Show me the money. Okay, here's the forest plot. Again, I just figured this function out during the weekend, so I don't really know why they have 6 statistics for one study. Maybe there are 6 groups or something. And if you click pool, what happened, I don't know. So there are not really 12 studies, but maybe 12 estimates. 有12个点，它就 then they pull together, and what they're finding is they are not really different. So again, this is showing the FMS versus FMD and the formal treatment modality, and are they different after you collect all those studies. Okay, and then you have the funnel plots for the publication bias. You have your diagnostic plots for, I think is for trim and fill analysis over here. And this radial plot again is going to show you is there any publication bias. If there's publication bias, this line will not be horizontal, so it's not very significant. Okay, and these are the trim and fill analysis. Trim and fill analysis nowadays is a very popular sensitivity analysis for meta-analysis. In the past, we might need lots of coding for this to happen, but now it's very easy. And let's move on to dichotomous outcome for, again, classical meta-analysis. So for dichotomous here, I still chose the oral hygiene topic, and what I have, I think they have lots of demonstration data here. But unfortunately, there are now no raw data here. I'm going to show you how to do the meta-analysis on JASP itself, but not on the Cochrane database. So here the topic I chose is for secondary bone grafting for alveolar cleft in children with cleft lip or cleft lip and palates. Again, I'm very naive, but I think it's a topic you will be interested. And they are trying to compare the effects of traditional iliac bone grafting versus grafting using artificial material. So all these options are very similar. I'm going to skip these, and that you see they don't really have many studies. They only have 3 studies here, but 3 is enough. If you only have 2, they won't be able to provide you the results. And the results is not surprising. It's not very different because they only have 3 studies. And actually not 3 studies, maybe 1 study and 3 results from Dickinson. Very old studies. All right. So what if you want to use their database to know how to do a meta-analysis? You can just click here, and you can find the very classic BCG vaccine database. You click that one. Oops, over here. So now let's check data first. You can see we have 13 trials. These are all studies, and they are really testing the positive results after you have the BCG vaccine. So there are treatment positive negative, control positive negative, and I think this is altitude, one of the variable of interest. And you could have effect estimate and the standard error, because here you need to give them the effect estimate, and they are supposed to teach you give you a link in terms of how to do the effect estimate if you don't really have the luxury to do that on your computer. And here are the same because we don't have any regression model here, but here the forest plots, funnel plots, rank test. You can just click that show you immediately. And again, all these diagnostic figure we wanna know. So you're gonna have the figure over here. You see the final result, but I don't know why they they're still running. Okay. Any question for the meta-analysis? Again, they don't have really much. Oops, not this one. They just have a very they cover the most of the function you need. Okay. All right, let's move on to machine learning parts, the sexy machine learning parts. Let's collapse all these meta-analysis here. So for the lower parts, we have the machine learning parts, and you can also click here. Sorry. And you will have regression part for continuous variable, classification part for binary variable, and clusterings for unsupervised method. I won't be introducing unsupervised method here today because we don't have enough time. So I'm gonna focus on classification here, because sometimes we just want to predict yes or no. So, but again, you can just also check their database to see they do have lots of example for both, I'm sorry, not this one, continuous and binary outcomes. So click this one, machine learning, and the iris flower is the famous one, and included in R. And they have some Tesco, telco customer churn, which is also a famous database on Kaggle, and maybe students grades and wine type. So if you choose student grades here, you can see it again automatically open the data. So here we have student, sex, age, and the major. What's the major? I don't know. Maybe job or something. All right. We have lots of variables up here. So since we are not familiar with database, so you can check the explanation here. They have the first grade, first period grade, second period grade. I still don't know what that means, but see what I did for that. They have the data splits for machine learning. Most of the model that you need to split training, validation, and testing. Don't just do training and testing. That's for conventional regression. You can do that. But for other machine that you need to fine tune your hyperparameters, you will need the validation parts. Excuse me. Okay, so this is a very simple example. Let's go back to our demonstration database. And oh, I didn't check what model they use. The model they use is regression boosting. So they want us to check the final grades. So that's the regression question, okay? And the machine they use is called a boosting machine. Boosting regression is a little bit different from the regular regression. Boosting is the method that you use to make some originally worse prediction better. 就有点像补习班哈。You should boost the students. You can just make it have a very good performance later on. So but they basically use all predictor in here, and you need to know the parameter here is mean square error, which is not very straightforward. Maybe I don't think they have some other here. Yeah. And sometimes we have the MASP is for proportion. It's like you have a denominator and the denominator. Say you want to predict the confirmed cases every day. So you want to know that how much different, but not the absolute number, but also the relative number. But unfortunately, they don't have the option here. Okay, let's go back to our example right here. So here is for classification. We have a lots of different methods we can use. The first one, they have, if you click that one, classification is actually a decision tree, not a boosting. So the first one I have is for a classification tree, and tree is still, I think, is very useful methods if you want to know the database before you really do some complicated modeling. Let's go back to our demonstration log. So again, this is for decision tree classification. Oops. Oh. Sorry for that. I'm using my laptop, maybe that's why it's not very smooth. How? Okay, it's right here. It's coming up. So this is for decision tree. And you can see, because I choose lots of variables that have missing data, because for biomarker we only test 500 of them out of 1400 subjects. That's why we have a smaller database. And here you can see for decision tree, because there are not so many hyperparameters to be fine-tuned, they are only training and testing data splits. And you can see the accuracy is about 0.89 over here. And again, here they have lots of evaluation matrix available for you. One is for the AUC, stand for area under ROC curve, because some some researcher also like to see the area on the precision recall curve. It's called AU PRC. It's not PRC. It's not Taiwan. PRC, again, it's not a joke. So precision here, you can see this is actually a positive predictive value. It's very, so again, JASP is for statistician to teach their students or to use. So statisticians are more familiar with the positive predictive value than the precision, which is defined differently in computer science. So in computer science or deep learning or machine learning field, precision is actually the same as our positive predictive value. Say you have a rapid test for COVID and you want to know the positive result, how accurate is positive results, then you will go to the precision. And the recall one is actually the same as our sensitivity or the true positive rates. Among all COVID patients, how many of them will be predicted as positive patients? So here it's not very good. I only have 0.25 for precision, 0.25 for sensitivity. But you have to know that positive predictive value will be heavily influenced by the prevalence, right? So everyone knows that the rapid test, the positive predictive value of a positive rapid test is more than 90% now, because our prevalence is more than 10%. Okay, so this will change with your data sets. If you have a highly prevalent database, you will have a higher positive predictive value. Okay, and the tree, the good thing of tree is they can just split a continuous variable automatically. So these are all the split point they have. But on the other hand, you have to know that each continuous variable will be split many times. So interleukin 6 here, and the second time here, and maybe third time here. And what does that mean? I think they have a tree here. This is a simple illustration of the tree. You can see interleukin 6 are first cut as the negative 0.11. Why is that negative? Because they are all standardized. You need to know that. So they are like a 0.11 standard deviation lower than the mean. If that's true, you will go this side. And then they check the comma scale, again, the standardized comma scale. And the interleukin 6 will appear again because here are lower than 0.011. And if it's further lower than 0.17, it's going to choose the p-selectin as the next biomarker. But again, the tree, although it's not very straightforward like the regression, you can use that to check the interaction between the biomarkers. And lastly, you can use the decision boundary to see if the model are really breaking your data very good. So take pose for example. The background is actually what the model is calling. So for this area, we don't really have much data. We have only these circle as the real data, but the model is doing this. The model is doing this is because it's not only checking the pose, but also lots of different markers or predictors, or people call it feature in machine learning field. Okay, so this is a figure that you can use to check your your final model, whether they are doing a good prediction or not, and why they are doing worse in some area. Okay, and I just want to see if they have the ROC curve. Maybe I just need to check here. Yeah. Here's the HTML file, and here is the ROC curve, which is not really good. So the simple tree is not doing very good here. So the ROC curve, this is perfect separation, so we are far from perfect over here. Alright, the next one is K nearest neighbors. Let's go back to our PowerPoint. I just want to show you some of the figure that you can know easier. Let's see. I should just just give me 1 minute. I should have everything, but it's not working. I will just show you the K nearest neighbor directly. Oops. So K nearest neighbor is categorized in the distance-based method, and the distance-based method also has a PCA, which is not included in JASP, but the support vector version is also included. All right, so the K nearest neighbor, because I'm going to skip the unsupervised method here, so I just want to show this figure. Yeah. Okay, so the K nearest neighbor is just, imagine you have an observation, and you think they might have a group, a cluster together. So you will take this, for example, I think they have 3 as their number for nearest neighbor. For 3 observation, if you have a cluster, that will have a prediction over here. And we already see the decision tree is they keep recursively, repetitively 重复的一直去do some data splitting. So this, like for the tree, is developing many different roots, many different branches. So that's why they have the decision tree over here. And for SVM, you have a boundary to split the data. So the kernel can have different kernel. So 不同的核心的支持向量机就可以做不同的data splitting. And then random forest is a very advanced decision tree, because for tree you only have one tree, and for random forest you have lots of trees. That's the basic difference. Okay. So let's check our nearest neighbor. But they don't really have a sexy plus like my slides. But all you have is the test performance. And you can see the accuracy is better than the decision tree. So let's check the k nearest neighbor. Again, you just plug in the targets, the one you want to predict, and then the predictors. All I have is these biomarkers, and then you just click the confusion matrix, which is actually a 2x2 table, to see how good your model is doing. And you can actually have the proportion, and then the plots is data splits, the classification accuracy, because the training model is going down and the validation test is going up, and that's when they call that 8 is the good number to have in their database. And remember, now we are testing our data many times, very close to the post hoc test in ANOVA. So you will want to do this in the, some people call that the whole bunch, the whole, they call the training and validation as the training data set. But some people just call it training and validation data set. But anyways, you can see they are using the training data to have the initial feeling of the accuracy or the performance of their data. Here they use accuracy. And they found that 1 number is not doing good, 2 is not good either, and 8 is a good number, and up more than 8 is the model is doing worse in the validation sets. But you have to be cautious, because the validation sets might not have many observations. Take this for example, we only have like 8% mortality. So maybe that's why the model is not really predicting well. But after the validation test, you will still have the tested results. So you can see the performance is, I think it's relatively robust here. And you can see the ROC curve is relatively well. Okay. All right. After the k nearest neighbor, again, you can just check the decision boundary to see what they're doing. You can see that they are very different from the regression tree. Now they're just checking their neighbors. And so these again are non-parametric method. The distribution is not very important. And next one is LDA. You can see LDA is very close to support vector machine, but the support vector machine, you need to have a vector to separate these observations. But for LDA is very similar to regression, and this you can just separate from red and blue. So they are very similar. 它们还是很像。So for LDA, you don't need validation sets. And here's are the similar outputs you have. Okay, and then these are the matrices to show you the within class correlation. So that's for linear discrimination and classification. All right, and here's are the performance. I want to move on to the more sexy models such as neural network, random forest, and support vector machine, although they are not really doing good in this example data sets. Part of the reason is for neural network, you will need far larger data set. 所以类神经网络或者是深度学习or deep learning, you will need 你要更大的资料才有办法。所以我们在别的资料是有比较好的表现的，但是这个比较小的资料。On the other hand, JASP is not really powerful, taking advantage of the GPU power. 所以它只有用 CPU power. It's only using CPU power. So that's why it's not doing that well in these complicated data set. Okay? So for neural network, let's check. Again, we have the same target to predict. And then all the predictors here. And very similar, the confusion matrix, class proportion. But they have the network weights here. And then for the data splits is now you have the luxury to split training and validation here. And then the training parameter is another thing you want to pay attention on. You can see they have different activation function. They have value, have logistic sigmoids. Sometimes you will have a rule of thumb to know that maybe for some data sets you need to use value, some data sets you need to use sigmoid. And then you can use the manual to choose how many layers you want to have for the neural network. It's over here. So you can just use the optimize method to let the machine to do the modeling for you. And let's check the result. You can see the training and testing are not really shifting really well from 1 to 10 generation. And then the performance of the machine is not really well as well. But again, sometimes the big model is not doing as good as the smaller models. So for random forest, let's check the result for random forest. Because it's tuning lots of parameters for you automatically. You need to give them training and validation data sets splitting. So here you can see the random forest is doing the best in terms of their out-of-bag accuracy, which is different from the test accuracy. The test accuracy is over here, but out-of-bag means when they are doing the tree, the forest randomly, what's the accuracy they have. So this might be overestimated. I'm more conservative, so I think the test accuracy is still the best one to use. So again, the random forest is not doing as good as our k nearest neighbor. But here they have the importance ranking, which is another thing we have to do after all those modeling. Because some people will think the AI model or the machine learning model are all black box. You cannot see through the box, so you will not buy it. So that's how you can tell people, say, hey, these are the difference we have. I don't think they are ranking well because you want to rank them. So, and there's no way to rank them now. But that means if you take this one out, the mean decrease in accuracy will be very small. So the bigger one will be like respiratory rates, interleukin 8. These are the parameters you want to keep in your random forest. Okay. And then, oh, I'm sorry, they do have a plot to rank them. So again, interleukin 8, respiratory rates, interleukin 6, temperature, etc. These are the importance positive. I mean the variable that are positive related to the outcome. And these are the variables that are negatively related to our outcome for age, CD64. So now the data are Now the model are making more sense now. And then again, there are decision boundary metrics. You can check if there are maybe there are some outliers that what you want to take out as well. All right. The last one is the support vector machine. Very similar structure. Again, the targets, predictors, table, plots, data splitting parameter preference, and then how you would use these. You can use linear, as I just demonstrated, or radial. Let me check the radial one, but we have to wait a little bit. At that time, let's check the performance of the linear results. Okay, so the performance linear support vector machine is not bad. The accuracy is 0.944. And again, these data set, for this data set, we don't really need complicated model. But be cautious about the ROC curve here, because I don't think it's a valid ROC curve. For ROC curve, because you sometimes you have many different cutoffs, so that will make the cutoffs, when you connect them together, they will make a curve for you. But here you don't have a curve, right? You don't have one observation. So I will just caution you to use the curve, because JASP doesn't have this function, but for other software we could just ask. I think they do have it, but you have to do that manually. You could just predict. No, they can only predict binary outcome. But for other package in R, we could just ask the model to give us the predicted probability. So using the predicted probability can just have a better ROC curve. Okay. I think I'm gonna stop here, because I think it's this is a lot of information for you, and I don't really have time to go through other options in JASP. But I think the most common statistical software is a statistical function is covered. But here they also have the mixed model. They have factor analysis. They have PCA. They have CFA, EFA. They also have some Bayesian methods, which is why they call it the JASP, because Jeffrey is a Bayesian. 他是贝氏的统计学家哈。So we have profits. This is the one to use to predict time series prediction. So I'm gonna stop here, since we have only 11 minutes left. Open to some question that you may have. 我们剩11分钟，所以不知道各位有没有什么问题哈？不管是软体的还是机器学习，我今天没有花太多时间讲机器学习哈。
好，陈教授，谢谢你的详细的演讲我想对我本身来说，我可能不太容易跟得上因为事实上对统计、对机器学习对我来说都是蛮困难的。那另外抱歉，有些演讲中有些杂音穿进来，常常有人忘了关掉 speaker。那我想我首先问一下几个一些问题。第一个，在我们是不是本身要对 biostatistics 跟 machine learning 比较熟悉，来用这个软体会比较好学习方便一点？
好，我先回答这个问题啊。其实这基本上就是一个统计软体哈。那所有的统计软体它都会内建一些教学的资料库跟教学的文件。那所以当我发现了这个软体的时候，发现第一个它是免费的嘛哈。那第二个是它的使用的功能也是跟我们习惯的这些 SPSS 啊Stata 或者 SAS、EG 的功能都很接近。那再来是它一直会进化，所以我的认知是它事实上有很多功能，我自己都觉得是这是很新的、很 cutting edge 的。所以就是除了教学以外呢，其实 我们还是可以知道说这上面有些功能是，如果你第一个我讲两段，如果你是第一个是初学者，你可以知道说这个其实是，是蛮在教高等统计老师会用的软体，好，所以你从这边去学，从一些基本的，然后学到进阶的上面的时候，你就会觉得，这其实里面的东西是蛮值得去看的。第二个就是说，因为它已经有一些比较进阶的功能，啊，那我常常喜欢讲的就是，如果当这些下拉式的视窗都已经做出来，那我们不做就会跟不上。当machine learning都是我们点选就跑出来，那就是表示说这个东西已经够稳固了哈。当然，像我刚刚示范的是因为我的资料库比较复杂，所以跑得比较慢。那比较小型的资料库事实上不会那么费力，然后是可以跑得动的。所以我会鼓励说，就是如果有心要做统计，不管是基础、深度的，然后或者是要教或者是带着学生做的，这是一个蛮好的资源。好，那像是更是像我们新的你有些觉得门槛很高的，那这个就是降低你的门槛了。所以我会觉得是它是一个资源，那你还是要花时间去学习。那当然你也可以跟人合作，在合作之前呢，你可以自己先跑一跑说，其实我的资料是跑得出来的，所以我会这样来介绍这个软体。
因为事实上我们中心也是有一些人已经是很熟悉SPSS 了哈。那你说这个软体跟 SPSS 的也是差不多，那所以从这边 SPSS 跳到那边，可能还要需要一段时间适应。不过听起来这个软体还在1点几版嘛，意思就是说它还一直在改善，听起来还是一个不错的，所以希望我们的同仁也可以进来学习。那另外一个问题就是说，在你演讲中，你常会说怎么还 still running？ 我意思说是不是软体的需求有特别？那我们在我们的研究中心是不是要准备一个特别你来讲到 machine learning 事实上它的需求对 GPU 的要求可能更高，是我们也需要 update 我们的所谓的硬体来做这些统计方面的事情。
这是像我的电脑现在用的笔电已经是3年的了哈，所以可能在这个的确这是跟不上。然后你也可以看到我一次就选很多的这个栏位哈，但是那个的确是我们自己在有 GPU 的机器上会做的事情，那的确它也就慢下来了哈。那 JASP 呢，它还没有用到 GPU 的算力哈，所以它应该只是一个入门的软体。那真的要去用那个 GPU 的算力的时候，可能还是要回到 Python 啊，可能R 有些也是有，但是就还是 Python 是比较实在的。所以如果真的像因为我自己最近也有几篇 publish 是跟影像有关的，那我们当时就是不是用个人电脑了，一定是用 GPU 的电脑，那甚至有些还是要算个好几个小时，才能把它算出来。所以如果真的中心要投入的话，但是现在这些东西也都不贵了啊。但是我要拉回来现在要买这些显示卡啊，那个价钱往上就算了但是还买不到呢。所以我们前一阵子有一个采购了，要买一张显卡，他说我现在不单卖显卡，你要就整台机器要跟我买那就是10几20万但是算起来跟有些微类研究已经是便宜很多了但是就是先准备好，可能先把预算挑高一点，那应该会比较容易买到，就是一点建议这样子。
好，谢谢。请问那我们同仁还有什么需要提出讨论或者是请教授回答的？林博士，
我有问题。
好，林博士请说。
就是陈教授好就是关于 machine learning 的这一块，因为JASP 它这里提到的应该是比较 traditional 的 machine learning 的这个 model 嘛，所以它在那个 neural network 的这一块的话，就没有 involve 到就是 deep learning 或一些就是现代比较就是没有现代的那些就是 machine learning 的些的function，那是不是它还是 focus 在所有的所谓的全连接层的这一块而已？所以我们如果是 image base 的话，就必须要去用 就是您刚说的那种 Python 或什么的，因为如果是以 JSP 的这一块的话，就是比较偏向传统的特征工程的这一块，我们还是必须要慢慢的去把这些特征项去 extract 出来，去 select 出来，才能够去用这一套软体来跑。是。
对，没有错。JSP 它并不是给 deep learning 用的这个软体哈，所以你可以看到它的是 fully connected 之外，它的层数虽然可以比较深哈，虽然也可以 by definition 它也算深度啦哈，就是 deep 有够深，但是说它不能直接把影像的拿来做哈，所以我们也不会在上面做影像的，所以影像还是另外一堂课啦哈。如果大家真的有兴趣，我们来跑跑 Python， 然后把一些这些示范的东西去跑跑看。是这样，谢谢。
谢谢。
请教我们还有什么其他问题吗？廖玉芳教授，廖玉芳教授在线上吗？那如果没有其他问题的话，我们今天再一次谢谢陈教授给我们的演讲，希望我们将来有什么问题还是能够继续跟你讨教，因为事实上我个人认为这些东西对我们的研究中都是蛮重要的一环，也是我们蛮欠缺的一环。好，谢谢你陈教授。
是，最后我再放一下那个我刚刚讲的这个 QR code 哈，如果大家这个今天的东西，因为后面有些没有讲到哈，包括那个资料库啦哈，就是示范的资料库，还有就是我的 email 在这边，如果大家有兴趣可以截个图啊，然后以后我们可以再联络，或者是现在 Team Plus 也都很容易找到人了哈。好，就希望有机会跟大家合作，谢谢谢谢。
好，谢谢你哦，谢谢
谢谢。
那我们今天早上的 meeting 到这边结束谢谢大家，
谢谢。